Welcome to questions 106 to 110 in Chapter 5. Question 106, read the math notes box in this lesson for information about alternative notation for sequences and write the first 5 terms of these sequences. So we've done the recursive before, but there is an alternative notation to this, and that's using the A sub n format. So make sure you read the math notes on this. On question A here, we're going to write the first 5 terms. If A sub n is equal to 2n minus 5, and we want to know what the first term n represents the term number. So if I want to know what the first term is, then I say 2 times 1 minus 5. Therefore, the first term would be equal to negative 3. And then if I wanted to know what the second term number is, I would do 2 times 2 minus 5. And the second term would be 4 minus 5, which is negative 1. And you can see that each of these is going up by 2. So to write the first 5 terms, negative 3, negative 1, just keep adding 2. And those would be your first 5 terms of the sequence. On part B, same thing, but this was written in more kind of recursive form where you have the now term and you're trying to find the next term. You are given the first term is 3, so we do know the first term is 3, and then we know each term is being multiplied by negative 2. So 3 times negative 2 is negative 6. Negative 6 times negative 2 is 12. 12 times negative 2 is negative 24. And negative 24 times negative 2 is positive 48. So on this one, it does have that similarity where it does give you the first term, and then this is the next term, equal to negative 2 times the now term, or the one that you have currently. Question 107, solve each equation. First part, we have a potential to set up a generic rectangle or use the distributive property, x squared plus 3x plus 2x plus 6 is equal to x squared minus 10. So we can subtract our x squareds and those will cancel. That'll leave us with 5x plus 6 is equal to negative 10. Subtract 6. 5x is equal to negative 16. Divide by 5. X is equal to negative 16 fifths. And so that's part A there, and then B, the one below it, we have a bunch of fractions. We could get rid of the fractions. One way we can do that is what is the common denominator of each of the denominators, 2, 3, and 6. And 7 doesn't have one, it's just over 1. So 6 is the common denominator. Everything can get multiplied by 6. So 1/2 x times 6 over 1 plus 1/3 x times 6 over 1 minus 7 times 6 is equal to 5/6 x times 6. Now I wrote them all out so that you could see them. So it looks like this. Each of these 4 things were getting multiplied by 6. So 1/2 times 6 is 3, so that's 3x. 1/3 of 6 is 2, so that's plus 2x. And remember, these can just cancel and give you 2. And then you have negative 7 times 6, which would be negative 42. And then those 6's cancel out and just leave you with 5x. So that's one way to do it. It's definitely not the only way. You could have just dealt with the fractions by combining like terms. But it does look like once we get done with this one, we get negative 42 is equal to 0, which will not work. So that is not a true statement. So our answer is no solution after all that. There's no value of x, so that will make that work. Alright, on to C, we have an absolute value. Remember when we talked about absolute value? If we cover this up right here, alright, and we ask ourselves, what can we plug in for that? We could either plug in negative 9 or 9. So once we erase this, whatever's underneath here, that's what we do, is we set it equal to negative 9 or 9. So we have 2 possibilities. 2x minus 1 could equal negative 9, or 2x minus 1 could equal 9. And then we solve both of these equations, add 1, divide by 2. On this side, if we add 1, divide by 2, we get 5. So 2 of our answers is -4 or 5. So x is equal to -4, comma 5. If you're going to write it this way, though, you got to use the curly brackets to indicate that it is a set. On D, once again, your denominators are 3 and 2, so we can multiply by the common denominator of 6. That means each of these terms, x plus 1 over 3, is being multiplied by 6. So we'll simplify that in just a second. And then x over 2 times 6. And then we'll simplify that as well. So when we multiply by 6, the 3 cancels with the 6, but there's still a 2 left. So it's 2 times the quantity x plus 1. And then on this one, the 6 divided by 2 is 3. So we're left with 3x. So we'll distribute, subtract the 2x, and get 2 is equal to x. So our solution is x equals 2. On question 108, we're looking at recursive sequences. We're going to find the first 5 terms and then define it explicitly, though. So we start with term 1, which is at 12. And each term is going to get subtracted by 5, or subtract 5 from it. So 12 minus 5 is 7. 7 minus 5 is 2. 2 minus 5 is -3. -3 minus 5 is -8. And now we need to write the explicit. Well, we need to know 2 things. We need to know the change, which we're subtracting or adding -5 each time. And we need to go back. This is term 1, term 2. We need to go back to term 0. And so if we do that, that would be at 17. So our explicit equation here would be t of n is equal to -5n plus 17. All right, on B, our first term is 32. So 32. And then each next term, n plus 1, each term after that, we're going to take 1/2 times the previous term. So half of 32 is 16. Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. And so if we want to write this in explicit form using a sub n, we will do a sub n is equal to, now once again, each term is getting multiplied by 1/2. But we still need to know our initial term of 0. So if it's getting multiplied by 1/2, then we'll times it by 2 to get back to the initial one. So that'll be a sub n is equal to the initial term, 64, times the multiplier of 1/2 raised to the n power. And so 2 different ways in terms of the notation on those. 109, multiple choice. Which line below is parallel to y equals -2/3 x plus 5? So for them to be parallel, their slopes must be the same. So we need to look at each of these. None of the 4 are written in slope-intercept form. So I'm just going to take each of the equations and rewrite them in slope-intercept form. So on each of these, because they're all written the same way, we're going to subtract the 2x. Subtract the x to the other side, or add, and then on this one we're going to divide everything through by -3. So y is equal to a positive 2/3 x minus 2, which means it is not parallel. So on to B. 2x plus 3y is equal to 6, very similar to the last one. We're going to subtract 2x again, but now it's a positive 3y equals -2x plus 6. Divide by a positive 3, we get y is equal to -2/3 x plus 2. So you can see that the slope is the same, so B is parallel. On C, it doesn't say how many answers we have, so we'll keep going. So we have 3x minus 2y equals 6. So we'll subtract the 3x, But you might notice right here that this is not going to work because the 3 and the 2 has switched places, so it looks like we are going to only have one answer. Negative 3x plus 6 divided by negative 2, but now when you divide, it's 3/2 instead of 2/3, so this one's not going to work, and either is D for the same reason. So it looks like our only answer on this one is B. Question 110. The graph at the right shows a comparison of the length of several gold chain necklaces, including the clasp, to the total mass. Write an equation for the line of best fit. Based on your equation, what would you expect to be the mass of a 26-inch chain? Now, because this is, we're all drawing our own line of fit, best fit, so our equations might be different, so part B might be different as well, but they should all be pretty close together. So I'm going to go ahead and try to draw my line of fit and then find a couple points so I can write my equation. Alright, so I think that's my line of fit. Tried to balance points the best I could. Tried to find 2 points. Let's see that intersects. It looks like this point right here would be a good intersection point. So if I go down, maybe it looks like 12. And if I go over, maybe 14, potentially. So let's call it 12 inches with 15 grams. And let's find another point. Here's another one. Looks like crosses nicely. So if I go down, maybe 20 as the length. And if I go across, maybe 24. So we'll call this one 20 and 24. So I'm going to use those 2 points to write my equation. 12, 14, and 20 and 24. So my slope, 24 minus 14, and 20 minus 12. So 10 divided by 8, 5/4, or 1.25 potentially. So it looks like our slope 1.25. And the y-intercept, it didn't actually cross the y-intercept at 0. So I'm going to have to go ahead and use the information given in one of my points in my slope to write the y-intercept. So I'll go ahead and use the first point with a slope of 1.25. So 14 is equal to 1.25 times 12 plus b. So if I take 12 times 1.25, I will get 15. 14 is equal to 15 plus b. Subtract 15 and I get b is equal to -1. Which, looking at that, b equals -1 doesn't make much sense with my line, so I'm wondering if my points that I picked, I didn't pick them accurately based on the line. Well, we'll go with what I have. Y is equal to m 1.25x minus 1. And once again, all our equations are going to be slightly different based on which points we chose for this one. This one's a little bit harder because we don't know exactly what those point values are. On B, based on your equation, what would you expect to be the mass of a 26-inch chain? So because the mass is the y value, I'm going to plug in 26 for y. 26 equals 1.25x minus 1. Add 1 to both sides. And then we will take 27 and divide it by 1.25. And when we do that, we get 21.6. And then this would be inches or... Alright, well, I made a mistake. So let's go back and fix it. I didn't realize I read mass of 26. I should have kept reading it. It's actually, we're finding the mass of a 26-inch chain. So I made a mistake. I will go back and fix it. My apologies. So it actually will be, instead of y, it'll be y equals 1.25 times a 26-inch chain, and then minus 1. So we got 1.25 times 26, and then we subtract 1 from it, and that would give us 31.5 grams. So sorry about that, but approximately 31.5 grams. Once again, it's all going to depend on what you made your line to fit and what point you chose to write your equation.